Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA 200-301. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Let's get started. In this lab, we will examine some network traffic using Packet Tracer's simulation mode feature. But first, let's take a look at the network diagram. There are two routers, R1 and R2, two switches, switch 1 and switch 2, and one server and one PC. The G00, G01, G02, and F01 labels indicate the network interfaces used to connect the devices. G means gigabit Ethernet, so these interfaces operate at a speed of 1 gigabit per second. You might also see it written as GI or GIG, but I usually just use G. F means fast Ethernet, so these interfaces operate at 100 megabits per second. You might also see it written as FA instead of just F. Now, these two series of numbers here, 192.168.1.0/24 and 10.0.0.0/24, are the network addresses. Routers are used to connect different networks. There are two networks displayed here in this diagram. The one on the left here includes server 1, PC 1, switch 1, switch 2, and R1's G00 interface. They are all in a single network, or subnet, a term you will learn about soon. So that's the 192.168.1.0/24 network, and the .100 for server 1 means that its IP address is 192.168.1.100, and the .1 by R1 means that its address is 192.168.1.1. Wait for the lesson about IP addresses coming up soon for more information on this topic. The other network is 10.0.0.0/24, consisting of R1's G01 interface and R2's G00 interface. Notice the .1 and .2, so R1 is 10.0.0.1 and R2 is 10.0.0.2. Hopefully that helps you understand a little bit about how to read a network diagram. Don't worry if you have no idea how IP addresses work or what that /24 next to the network addresses means. That will all be explained in a video coming soon. So let's get started on today's main topic. I'm going to use Packet Tracer's simulation mode, which you can activate here in the bottom right. Now I can click through here, and you can see various network traffic being sent around. Let's take a look at some. At device switch 2 means that switch 2 is the one sending out the data. It says type STP. STP is the spanning tree protocol, a layer 2 protocol you'll learn a lot about in this course. Let's click on it and notice here the 7 layers of the OSI model, and STP has information in the bottom 2 layers. Let's look at the layer 2 header. Notice it says layer 2, IEEE 802.3 header. You might remember that IEEE 802.3 is the standard number for Ethernet, so this is an Ethernet layer 2 header. Let's look at some of the information here. Down here it shows some information about the process, and notice here at number 2, the device encapsulates the PDU into an Ethernet frame. There's the encapsulation process I talked about in the lecture video. Let's take a look at the layer 1 info. Notice that the information is the two interfaces that it sends the frame out of. Information like the physical ports or interfaces on a device are layer 1 information, because it is the physical layer. Now let's look at another bit of network traffic again. This time at device R1, and the type is OSPF. OSPF is a layer 3 protocol. It's used to discover the best paths to different networks. You'll learn a lot about it too in this course. STP only had layer 2 and layer 1 information, but OSPF has layer 3, layer 2, and layer 1 information. Notice in the layer 3 header, source IP address and destination IP address. Remember, IP addresses are layer 3 information. Next, to look at some traffic that includes information all the way up to layer 7, I will go on PC1. PC1 is using a protocol called DHCP to automatically receive an IP address. To generate some DHCP traffic, and DHCP is a layer 7 protocol, I'll get PC1 to release its current IP address and then renew it. When you click on a PC in Packet Tracer, you'll see this screen. Click on Desktop, then Command Prompt to access the PC's command prompt, which functions like a Windows command prompt. Type ipconfig, and you can see the current IP address here. To release the IP address, type ipconfig/release. And now you can already see a DHCP message on PC1. I'll type the next command too, to renew the IP address. It's ipconfig/renew. Now let's check one of these DHCP messages. Notice information all the way up to layer 7, except layers 5 and 6. That's because in the TCP IP model, which is the model actually in use, layers 5, 6, and 7 are all combined into a single layer called the application layer. So you're not going to see any layer 5 or layer 6 information, but you can consider it to be part of the layer 7 information. Then there is layer 4 information. If we click on it, it says the device encapsulates the PDU into a UDP segment. Remember, the layer 4 PDU is called a segment. Layer 3, layer 2, and layer 1 information is present as well. Now, if I just press the play button in the middle, it will slowly play through all of the different messages being sent through the network. That's all for this lab. I just wanted to show you the OSI and TCP IP models at work on a network. Your understanding of the functions of these layers might still be a little unclear, but trust me, you'll understand things better as we start to actually learn about these different protocols that operate at each layer. Thank you for watching. That's all for this video. If you want to show your support, please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. I accept donations via cryptocurrency or Patreon via the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. Click the link in the description to check out